There are two energy products that can be changed into mechanical energy through the heat of combustion. There are two significant types of fuel. There's fossil fuel and biofuels. Fossil fuels refers to the power formed through natural processes such as anaerobic deposition of the dead organisms that have been buried for a long time, and dead organisms that contain original organic molecules from photosynthesis. Fossils are associated with very high combustions of carbon, petroleum, natural gases, and coal. Fossils are categorized as non-renewable fuels because they take a very long time and many years to form again. Within this experiment, we took two different fuels, wax, paraffin, and isopropyl alcohol. The fuel that is produced can contain either saturated or unsaturated molecules. Saturated molecules refer to a situation where a hydrogen molecule takes the carbon atom present with a single bond. Unsaturated molecules refer to a problem when the carbon atoms presented may be shared with three other hydrogen atoms, forming a double triple carbon bond. The energy produced is measured by the unit known as joule. Saturated hydrocarbons release more energy per molecule than unsaturated hydrocarbons. Biofuels in this experiment are categorized as renewable energy sources since production is repeated and the fuels repeated by the biofuels mass. Domestic wastes are readily available every day, and also plants keep on growing and thus making fuel. Short-chain molecules release much more energy compared to long-chain molecules. That's because fossil energy is non-renewable since the dead organisms take time to decompose or form fuel. During Module 6 lab, we took comparisons of fuel canister and tea candle. The tea candle was found out to produce more calories per gram. This event is because the candle is made up of wax that contains a very high percent of paraffin. Unlike the fuel canister, paraffin burns very rapidly, thus producing more energy, resulting in more calories. Fuel canisters burn faster, but less energy is emitted. Therefore, there is an incomplete combustion, resulting in low calories. Table 1 shows the mass and density of distilled water. For mass of a 10 milliliter of distilled water was 9.45 grams. Density of water was 0.945. Temperature of water was 23 Celsius. Table 2 is the calorimetric data. We have the different fuel sources, the fuel canister isopropyl/water, and the tea candle paraffin. Empty fuel canister was 50.62 grams. The initial mass of fuel was 75.66 grams. Final mass of the fuel was 74.00 grams, and the initial temperature was at 23, and at the final temperature of 58. With the tea candle, we had 9.84 grams for initial mass, and then final mass was 9.62. The temperature was 23 Celsius, and the final temperature was 35 Celsius. I did initially have a hard time keeping the candle, the fuel canister lit, and so I'm not sure if that final result resulted in my temperature being at a lower rate. Table 3 was a little bit harder for me to complete, but I worked out my math for the information. Therefore, getting in Table 3 fuel canister isopropyl water at 22 Celsius and the tea candle at 11. Calories absorbed by the water under the fuel canister was 87.03. Under the tea candle was 43.51. Grams of fuel consumed was 1.66. And for the candle, 0.22. Calories per gram for the fuel was 52.42. And for the candle, 197.77. Based on my calculations the fuel canister was found to be more efficient as compared to the candle wax. This result is because while the paraffin is made up of mostly hydrogen atoms, the fuel canister is made up of hydrocarbon and oxygen. The feature makes it burn very fast since the oxygen present supports combustion, and candle wax burns rapidly, but lack of oxygen lowers its efficiency. To compare its energy output from the paraffin wax and the isopropyl alcohol, I had to hypothesize that the dithyrylene glycol heated up together with the paraffin wax and produced much greater heat in a brief period. This event is resulting in the diethylene having a significant temperature change compared to the other results. This result is because of its components. Apart from being made up of hydrocarbons, the compound contains oxygen atoms that supports combustion. The oxygen presents acceleration burning and thus reducing the amount of heat produced. As mentioned previously, there were errors within this lab experiment. There are various sources of errors that could take place. They can range from instrumental errors, environmental ones, inadequate procedures, and even human mistakes. I certainly might have done some. Errors can occur in two ways, randomly and systematically. The possible source of error in laboratory comparisons of fuel is that they can be calculation errors. Different values can arise from the varying size of fuel canister and paraffin candles used in the experiment. Even though received, standardized in reality, there will always be a slight difference due to varying size of fuels used in investigation. For the extension question of this portion of the lab, I took the number 2,800 kgs divided by the 40 and got 70 grams. My conclusion is that the methane is more efficient than alcohol, but wax is the highest efficiency. However, you could not use wax to heat up your house or even use it in your car.